7.6. We are doing natural logs, and everyone freaks out because now instead of the word log, you get this. Well, really, you get this, which I'll probably write this way, just because this sometimes freaks people out because they think it's one N, and I don't want you thinking it's one N. So I'll probably write it the cursive way for now, just so that you keep it straight when I put something out in front. You don't think, like, if there's a 2 out in front, it's the natural log times 2, not 21n, okay? But natural logs are not as scary as they seem. It's still a log. It's just not the log that we're used to. Here's how I want you to think about this. First of all, if I give you this, okay, what's your base?
10.
This is a base of 10, okay? If I give you this, what's your base?
2.
A base of 2. Okay, so if I give you this, your base, still a log, okay, but now it's a base of e. Okay, but you will never see it as a base e, okay? This is essentially saying you won't ever see it like this. I'm just explaining to you what it means, but they will never write it this way. Basically what we're saying is the log of e, log base e, sorry, of x, it's the same as saying the natural log of x, okay? But this way is not how they write it. They write it this way, but it means this, okay? So when we evaluate something like this, if it's log base 2 of 2, what does that equal? 1, okay? So let me introduce you to my friend Lenny. Okay? This is my friend Lenny, the natural log of e, Lenny. Think about what this is saying right now. It's essentially saying the log base e of e is what? 1. So Lenny is a little 1-year-old. He's so cute, right? Little Lenny. He's always 1. He will never grow up. He's like Peter Pan. So whenever you see the natural log of e, think 1. It is always 1, and that will simplify your life so much. All right. You thought Peter Pan was Tarzan? Nope, definitely not Tarzan. All right, let's evaluate some natural logs. Remember, when we say evaluate, what should your answer be?
Wait, what is log? A number is e. Oh, that's L, not e. Oh, girl.
This?
No, the other one.
E, yeah, so e to, this is basically saying e to what power equals e? It's 1. So the natural log of e will always be 1. Okay? When we evaluate, what do we get? A number. Okay, so when they say evaluate this natural log, they want a number out of it. Okay? All right. First one. Sorry, I can't read my writing right now. So the natural log of e cubed. Now, there's 2 different ways you can do this. You can do it using properties, or you can do it using exponents. I personally would prefer properties here, because look what happens. If we use the property that says this exponent goes out in front, then it's 3 times the natural log of e. There's our good friend Lenny, who is worth what? 1. So it's saying 3 times 1 equals 3. Okay, so you can do that, or you can think of it like this. This right here is an e, essentially, right? Log e, log base e. So you could think of it as e to what power equals e to what power? That would be 3. Okay? So I don't care if you do properties or if you do exponents. They will both get you there. I just feel like the properties is good practice for you because you do the properties a lot more, or you need to understand. This is Lenny. Lenny's 1. The natural log of e is always worth 1. That's the value of natural log of e, 1. Every time. Okay? You're going to see Lenny a lot today. How about this one? If I give you 12 times the natural log of e to the 2nd power, okay? Using properties, we would take this 2 and do what with it? Put it out here. So you're doing 2 times 12 times the natural log of e, 24. Because the natural log of e is 1. 2 times 12 is 24. Okay? It's good, right? Who doesn't love Lenny? Okay. How about this one? 2 times the natural log of e over 7. Well, do you see Lenny?
Yeah. So 2 times 1 is 2. So
2 times 1 divided by 7 is just 2 sevenths.
Oh, okay.
Right? Look for Lenny. He's everywhere.
That's not good. Let me go back.
Okay, sometimes you're just going to get something like this that is not, you can't do e to what power equals 5. We can't move anything around. Sometimes you just need to plug it into your calculator. Plug this into your calculator and see what you get. Give me 4 decimal places. Did you find the natural log? It's right below log, right? Okay, do you all see it? Capital L, capital N. You should be getting 1.6094. Okay, so sometimes you're just going to calculate it. Put it in your calculator, get your number. Anyone not finding the natural log?
Why'd you divide by 7?
This was the problem. It started like that.
Oh.
Yeah. Okay? All right. Example 2. We are going to rewrite these as a single log. Okay? First one. Let's say we have 2 times the natural log of 3 minus the natural log of 10. Okay? Now, if we want to rewrite it as a single log, that means we can only have one ln in the problem, right? One natural log. So, one of the things you need to do is get this 2 out of here. So we're going to turn that 2 into an exponent, okay? The other thing is you're subtracting, which means we're doing what? Division. So if I take 3 squared, that would be 9, and we're going to divide that by 10. So as a single log, this would be the natural log of 9 over 10. Okay? So good, right? You love it. All right, 3 times the natural log of x minus 2 times the natural log of y.
You put 3 over x?
Not 3 over x.
I meant.
Oh, physically move it to over the x. Yes, we are going to move this here. We're going to move this here. And what operation are we doing? Division. So it's going to be the natural log of x cubed divided by y squared. Okay? And that's all we're doing. We're just simplifying right now. We're not solving for anything. We're just simplifying the setup. What? Oh, he's 1. He's taking a nap.
Well, Lenny needs to wake up.
Yeah, we'll bring him back. All right, how about this? No, you may not take a nap. 5 times the natural log of m plus 3 times the natural log of p plus the natural log of 10. Okay, so we want a single log. You're going to do multiplication. What do you got to do before you multiply? your exponent. So move this guy over, move this guy over. So you have the natural log. So it's going to be m to the 5th, p to the 3rd, and 10. Now, we want to write that in standard form. So put the 10 first. Then you can do m to the 5th, p to the 3rd.
Okay, that it? Oh,
That's it.
That's beautiful.
Beautiful. I know.
We're done.
All right, example 3.
Oh, lemons? Right.
Yes, please take some.
Oh my gosh, I did not mean to do that.
I'm kind of a mess right now.
I just meant to take one, but it sticked up one.
All right, example 3. We are going to expand the log.
She called me a mess.
Well, I mean, you don't want to peel your orange.
Well, I mean,
Then you take all of my stuff. Okay, we're gonna expand this. Now, don't let a radical freak you out. You don't, it's okay, it's okay. If we're gonna expand this, let's break it into the two pieces that we have, right? We have the natural log of 5. We're multiplying, so we need to do what? Add. So the natural log of the square root of y, okay? From here, what do you got to do with that square root of y? How can we rewrite that? Make it an exponent. Okay, so it's going to be natural log of 5 plus the natural log of y to the 1/2, right, is the same as the square root of y. What do we do with that 1/2? Move it out in front. So it's going to be the natural log of 5 plus 1/2 times the natural log of y. I love that I get it right in cursive, guys. So pretty. I love cursive. And we're done, right? That's expanded. You don't want any exponents in that expanded form, so we get rid of the exponents and we get rid of the multiplication, turn it into addition. Okay? Are we good? Okay. 2 more big examples, but with 3 under each. So, you know. Okay. What? Yeah, just one quick one. I feel like we've done a lot of expanding logs. Yeah? Okay. All right. Now we're going to do natural log equations. And the only difference now, right, equations have an equal sign in them. Instead of just being an expression, now it's going to be an equation. So we're going to be doing some solving. So for this first example, example number 4, we are going to solve and round to 3 decimal places. Okay, now what we're going to do right now is essentially what we did yesterday. It's just that now we're doing natural logs instead of a log base 10, okay? But the process is really the same. So this, hold on. Can I move up, or are you writing the blue right now?
I'm writing the red.
Okay.
Okay, you're good. That was, yeah, I called you sometimes.
It's all good. Okay, so here's what the problem looks like. It's the natural log of 3x plus 1 equals 5. And if you think back to what we did yesterday, the first step, really of what we've done a lot of, what has the first step always been?
Isolate.
Isolate. You guys are so good. So we're going to isolate by subtracting 1. Okay, so it's going to be the natural log of 3x equals 4. Okay. Once you get there so that it's isolated, all we have is the natural log on that side. Hey, remember how you weren't going to talk right now? Remember that? Yeah. Now we need to get rid of that natural log. And the way that we do that is natural logs dealing with e, right? A base of e. And natural logs, the inverse of a log is an exponent. So we're going to make this an exponent to get rid of that natural log. So what we do is we do both of these, the left and the right side, e to those powers. So it's essentially like you're taking an e and putting it here. This is your power, and an e with that power. Okay, so it's going to be e to the natural log of 3x equals e to the fourth. But really what happens is, because these are inverses, they just get rid of each other. So really, it's 3x equals e to the fourth. Okay? And then from there, all you have to do is divide by 3. So just plug into your calculator, plug this in so you know you're plugging it in correctly. E to the fourth power divided by 3. What do you get?
Wait, so E cancels out at 1.
These two are inverses, so they can't, it's like addition and subtraction are inverses, right? They get rid of each other. So it goes away. 18.199. Okay, let's do another one. Sorry. I'll slow down. I'm not trying to be speedy. Just in my groove, you know?
I know, it's just like the speed one the other day when it wasn't fluctuating.
All right, new problem. 2 times the natural log of 8x equals 1. What do we have to do first? Isolate. So we're going to do what to isolate? Divide by 2. Divide by 2. Okay, so this is gone. So we have the natural log of 8x. Yes.
Wouldn't that be an exponent?
You could think of it as an exponent. I'm not going to, but you could.
It's kind of ugly.
How would you do that?
Like, would it still work even if you didn't make it?
Well, because you would have to take 8x and square both of those. So 64x squared, and then you would be taking so it'd be 64x squared equals 1. I think I'd have to work it out and see if that works, but I think it would. But yeah, we're trying to isolate, right? So I'm gonna get that 2 out of there. So right now, it looks like that. Yep, get out. Now what do?
You're gonna like do these.
Put your e's in. There is a bug flying around here. It's really bugging me. So you're gonna do e and e, right? This goes away, so you're left with 8x equals e to the 1/2 power. What do you do from there? Divide by 8. And I don't care, you guys. You can plug that in and take a decimal and then divide by 8. I would just plug it into my calculator, e to the 1/2 divided by 8. Just make sure if you plug it into your calculator that you get out of the exponent when it's time to divide by 8, right? You're going to arrow over.
Yes.
You guys will arrow over that way. So divide by 8, you get, what does that come out to? 0.206. Okay, maybe try plugging that one in just to make sure you know what I'm talking about with the whole get out of the exponent thing. Okay, last one of this type, and then we're almost there. Natural log of 5x minus 1 equals 2. Isolate. No. Trick question. It's already isolated, right? When there's the parentheses around it, you're taking the natural log of that whole thing, okay? So if it's already isolated, then we're going to do e to both of those powers, right? That cancels this out. You get 5x minus 1 equals e to the second, okay? And again, you may leave this in your calculator. Maybe you just want to plug e to the second in. So e to the second is 7.3891, okay? Then you're going to add 1 to that. So add 1 on your calculator, plus 1. Hit enter just for the sake of not making a silly mistake. So right now you have 5x equals 8.3891, and then you're going to divide by 5. So x is approximately 1.678. Okay? Any questions? Okay, last type. Exponential equations. So when it's base E, instead of taking the log of both sides like we've been doing, we're going to take the natural log of both sides, right? So, example 5, we are going to solve these problems. So if it's e to the x power equals 3, okay, we take, we take the natural log of both sides. So the natural log of e to the x equals the natural log of 3. Do you see what we can do here?
Why isn't that a big group? I mean, a lower group. A top group.
It's reading.
Why isn't it an exponent?
X.
It is supposed to be an exponent.
3 is an exponent, but we're not putting it into exponential form. It's in exponential form. We're taking it out of exponential form and putting it into the log form. So then it's not treated as an exponent then. Just like we did with the regular logs. Yes.
On our quiz, for this, will you tell us which is which, like how it's going, like
Natural log or
solve this exponential equation or expand this, or do we have to know?
it will say like expand
Okay.
or make a single log,
Okay.
right? So you're trying to condense it down to one log.
Yeah.
Yeah.
That's what I was
Okay, when there's an exponent with the natural log like this, what do we do with that exponent? Move it to the front. Okay, so you have x times the natural log of e. Lenny woke up from his nap, guys. What is that? X times 1, right, is just x, because this is equal to 1. So x equals the natural log of 3, and you just plug that into your calculator. Natural log of 3 is, to 3 decimal places, 1.099. Okay, this, maybe make a note. You're just plugging it into your calculator. I feel like everyone wants to try to do something with that. Plug it in. Okay? Letter B. If we have 3e to the x plus 2 power equals 15. Do you know what to do first? Isolate. How do we do that? Divide by 3. Okay, so we get e to the x plus 2 power equals 5. What shall we do next? Move what? What? Right, we need to take the natural log of both sides. So it's going to be the natural log of e to the x plus 2 equals the natural log of 5. One thing I want you to notice here, this is not 1 to that power. Okay, Lenny is not ready yet. What do we have to do first? You got to move this out front. So it's going to be x plus 2 times the natural log of e equals the natural log of 5. Now you can treat him as 1. Okay? So really, this is x plus 2. You don't need parentheses anymore. Let's just take those away. Because all you're left with is x plus 2 on the left, because this is 1, right? That's 1, equals the natural log of 5. What do you do? Subtract 2. So you're going to plug in the natural log of 5 minus 2. Make sure you end your parentheses here again. Okay, if you don't end your parentheses, you're going to get a weird answer. So natural log of 5 parentheses minus 2, and you get Negative 0.391 I have. If you round up, yeah. Okay? How are we doing? Do you love Lenny? Yes? Okay. Last one. 8 minus 3e to the x over 2 equals negative 4. What do we do first? How do we isolate?
Subtract 8.
So we're going to subtract 8 first. Minus 8 minus 8. You get negative 12 is equal to negative 3e to the x over 2. Now what? Divide by negative 3. Right now we're multiplying these two, so divide by negative 3. And you get e to the x over 2 equals 4. What do you do? Take the natural log of both sides. So it's going to be the natural log of e to the x over 2 equals the natural log of 4. Move that x over 2 out in front. So x over 2 times the natural log of e equals the natural log of 4. I don't have to see all this work from you, by the way. Like, if you're doing parts of this at the same time, that's okay. But do show me your work, because the more you show me, like on a quiz, the better chance I only take a half a point off instead of 3 points off, okay? What is this? X divided by 2, right? This is Lenny. Lenny's 1. So x divided by 2 equals the natural log of 4. And then how do you solve? Multiply by 2. Make sure you put parentheses here if you're going to plug that all in one shot, or just hit enter. Hit the natural log of 4, enter, then go times 2 if you're worried you will plug it in wrong. So x comes out to
2.77.
exactly 2.773. Es todo. Por hoy.